Hey guys, it's Ms. Damaso. We are talking today about our week 4 video 2 notes. We are starting section 8.2, some statistical studies and sampling methods. So this one follows our 8.1 that we were just talking about with some statistics and some of that vocabulary that we were looking at. Today we're going to learn a little bit more vocabulary, and we're going to take some of those same ideas that we learned in our last video, and we're going to kind of put them in motion here. Remember that you can find both the notes and the homework within the week 4 video 2 assignment on Edmodo, so that you can follow along with me. And just like always, if you want to print them and follow with me, you can, or if you want to just write everything in your notebooks, you're also welcome to do that as well. Okay, so we're going to start here with our introduction. So Jancita and Felix were each asked to design a study to answer the question, what proportion of students at this school listen to music while studying? So I've got two different studies you can see over here on the left. Jancita's, what it looks like she did is she asked a couple people who she knew. She got some people that said yes, they listen to music. Some people said no. And then for Felix's study over here, it looks like what he's done is he has observed some kids listening to music in the library. He tallied up the people who were listening, and it looks like he had a total of 100 students that he surveyed. So, letter A, what group did Jancita select from to conduct her study, and what group did Felix select from? So if we're looking over here at the people that Jancita picked, it looked like she picked a grouping of people either that she knew, maybe they were friends or something. So it looks like Jancita's group was either a group of friends or people she knew. So we'll just call it a group of friends here, right? Because she's got all their names. Obviously, she knows who these people are. Felix, down below, looked like he picked 100 students that were just in the library. So he selected 100 people, or 100 students that were in the library. Okay. Letter B. How did Jancita choose which member of her group to question, and how did Felix choose which members from his group to observe? So out of the people, the grouping of people that she picked here, Jancita, she looked like she really only picked her friends. So while maybe these were all a whole bunch of people that were standing around, she looked like her sample was really just her friends. And Felix looked like he was either questioning or observing those students that were in the library. So it looks like he was looking at all students in the library. So maybe it was some of his friends, maybe it was some people he knew, maybe it was people he didn't know, but it looks like he kind of asked a lot more people. So letter C, look for relationships. Who designed a better study, Jancita or Felix? Explain. So if we look at Jancita's grouping over here, like I said, she only really picked her friends, it looked like, and she has 1, 2, 3, 5, 6, 7. She's only questioned 8 people. So she's questioned 8 of her friends. Whereas Felix looks like he has questioned 100 kids, some of who are his friends, some are who are not his friends. So because there's a little bit more like variability here, there's a little bit more people that he doesn't necessarily know, there's a little bit more kind of variance in who he picked, Felix looked like he's got a better grouping of people that he's asked, and he also has way more people. So his data is going to be a lot more accurate than Jancita's, right? Because if I just ask my 8 friends, hey, what do you think of this? Versus if I look at 100 people that I know or maybe don't know, this one is going to be a better study. So Felix is definitely the person that designed a better study. So one of the reasons is because he has a larger population. So instead of just 8 people, right, he has 100 scholars. And then he also has a little bit more variability, right? So he also has people that maybe he knows and people he doesn't know, so he has a better representation of students. So it's not just his friends. He's got friends, not friends. Maybe there's some teachers in there. Who even knows? Well, actually, that's a lie. He wouldn't have teachers, right? Because the question's all about students. So that's actually probably a way better scenario. So today, what we're going to talk about is looking at two different studies and really deciding which one is the better study and why is it better. This study over here has a lot more something called bias. And this one over here that Felix is doing doesn't have as much bias within it. So this makes it a better study. So bias is just a representation of who's within it. So just as a little bit of a review, working with samples. In statistics, we work with data. Data can either be categorical, right? So it's data being put into categories like political preferences or your favorite color. Those are categorical data. Or it can be quantitative, right? Which has to do with quantities, numbers. So it could be your salary, what your weight is, right? Statisticians survey a population to collect data or take a census when all individuals are surveyed, right? So population is the whole grouping of people that you are talking to. So again, as a little bit of a reminder from the last video, a population is a set of all members of a group that you want to know something about, right? So the whole grouping of people is going to be your population. If you're taking a smaller subset of that population to be studied, that is called a sample, right? So it's a smaller grouping of people. So a blank is to measure that describes a population. So population, if I'm describing a population, that is a parameter. And if I am describing a sample, I'm using a statistic. And an easy way that I remember which one goes with which is parameter and population both start with a P, statistic and sample both start with an S. Look how nice and easy that is. A little bit more vocabulary that we're going to talk about in our next video, but I just want to touch on for this one is something called margin of error. So a margin of error is an estimate of error in a sample population, or excuse me, in sample proportion, based on something called the standard deviation, which we're going to talk a little bit about in our next video. The larger the sample size is, okay, so the more people that I am asking questions to, the smaller my margin of error is. So you want the more people that you can get is better, is always going to be better for a study. So if you ever watch like the news and they talk about, oh, we talked to 10 people and here's what they think. Well, that has a really high margin of error because it's not a lot of people that you are talking to. It's not a lot of people that you're collecting data from. If you watch the news and they're talking about they talked to 1,000 people, well, that's a little bit better of a grouping of people, and so my margin of error is going to be smaller. The sample proportion is the ratio or a fraction of the number of time an event occurs X to the sample size N. So for example, that means the number of times somebody does something over the total number that I have. So that's like saying if I said, okay, 70 out of 100 scholars are currently passing math class, right? That would be 0.7, which is 70%. So a ratio means whatever your fraction is, and then you can always change that into a percent. Now, when we are conducting a study, there are different ways that we can sample our individuals, okay? So sampling is how do I make that population, if I'm trying to take a smaller sample of that population, there are a couple of different ways that I can choose what my sample's going to be. The first one is a random sample. So each individual in the population has an equal chance of being selected. So the more random it is, the better your study is going to be. A self-selected sample is when members volunteer to participate. So it's if I say, hey, do you want to do this survey? And you say, yes, I do want to be part of that survey, or no, thank you, I don't want to be part of that survey. So you probably get emails about that all the time. That's a self-selected survey. Convenience is probably what you think. It's when members are chosen because they are easily accessible. ACC. Easily accessible. So it's something like if I were to ask a question about how many people like to eat jelly donuts and I'm standing outside of a donut shop, that would be people who are easily accessible to me. A systematic sample is when members are chosen using a rule. So such as something like every nth person in the population. So that could be like if I want to know how many people like those jelly donuts, well, I'm going to ask every third person that walks in the door or every fifth person that walks in the door. That is a rule. A stratified sample is when the population is first divided into groups, then members are randomly chosen from each group. Okay. A cluster sample is when, again, the population's first divided into groups and then a sample of the groups is randomly chosen. Okay, so notice that these are two a little bit different. Stratified is more, I have a population and I break it up into groups. Maybe it's like boys and girls. And then from each group, I pick a random 5 girls and a random 5 boys. A cluster is when I divide into a group. So maybe it's a girls versus boys. And then a sample of the groups is randomly chosen from those girls and boys. So maybe it's just one or the other. So now we're going to do a little bit of practice classifying a sample. So in each one of these questions, we're going to determine which type of sampling that it is. Okay, so it's going to be one of these 6 answers right here. Okay. The editor of a skateboarding magazine wants to find the reader's favorite places to skateboard. The latest edition of the magazine included a survey card, and 429 readers completed the survey and returned the card. So I'm giving out a survey to everybody, and these people are volunteering. 429 people are volunteering to answer it. So because they're volunteering, this is a self-selected sample. Okay. Number 2. The Student Council Dance Committee of 5 students, because I can zoom in a little here, sorry. Okay. The Student Council Dance Committee of 5 students is going to survey their 5 homeroom classes to determine whether to hire a band or a DJ for the upcoming Valentine's Day dance. So, there's 5 students, and they're going to survey just the 5 homeroom classes that they happen to have. So they're not going out of their way to find random people. They're not surveying random people or a rule. They're saying, hey, you're closest to me, so we're going to pick the 5 homeroom classes that have to do with our 5 students. Well, because I'm just picking like the closest thing, the easiest thing, it's easily accessible, that means this is a convenience sampling method. Okay, convenience, right? What's easy for me to do. Ooh, okay, next one. Number 3. A state senator randomly selects 200 voters from each county to call regarding issues related to an upcoming legislation. So he's randomly selecting 200 voters from each county. So they're in a county, right? So that means that he has divided them into groups, and then he's randomly choosing 200 voters from those groups. That means this is a stratified sampling method. Number 4. A research group selects every 20th person on a list of registered voters in a state to call about their intentions to vote in the next election. Well, this is a rule, right? I'm saying every 20th person. Because it is a rule, this is a systematic sampling method. All right, last one. A national news anchor stands in Times Square on New Year's Eve to question people about their New Year's resolutions. Well, I'm just standing somewhere in a random place, has nothing to do with anything, on New Year's Eve, and I'm just questioning anybody that comes and walks by. Everybody that walks by has an equal chance of answering the question, right? So this is just a random sampling method. Okay, next thing, bias. So we talked, I kind of mentioned it a little bit earlier, but now we're going to talk about what bias actually is. So bias in data collecting is this: when a part of a population is underrepresented or overrepresented in a sample, it's said to be called bias. So if I have too many of one type of people and not enough of another type of person, that is considered bias. That means it's not considered a good sample or data survey. By choosing a random sample experiment, researchers can help avoid bias in gathering data. So you always want to avoid as much bias as possible. Now, if we go back to those 6 different methods, random is a great method. It has little bias, and that's always kind of the one you want to strive for. So this is a good one, as is a systematic is also, because you have a rule, it kind of gives you a little bit more variability. Same with a stratified and a cluster. Self-selected and convenience are probably the 2 that have the highest risk for bias. A high risk. So we always want to try to avoid these 2 different types of sampling if we can. If we can't, and that's what we have to do because of the conditions for whatever reason, we'll do those. But to the best of our ability, we want to make sure that we really avoid self-selected inconvenience, because it can over or underrepresent, and it's going to have a lot of different biases in it. Okay. So now what we're going to do is we're going to identify any bias in the sampling methods below. So we're going to look at the scenario and we're going to determine, does this have bias or does this not have bias? And there's always going to be a little bit of bias, but we want to try to get the least amount possible. Okay, so here's our scenario. A local news program reports on a proposed gas tax increase to be spent on new roads and bridges in the county. The program wants to identify what percent of the population in its viewing area favors the tax increase. So they want to know how many people in their area are for this tax increase. So number 1. A reporter is sent to interview people on the street near the county courthouse. So I have to say, okay, if he's near the county courthouse, which is where the bill would be, if he's there, that's a convenience sample. So he's just interviewing people that are right around him, that are easily accessible. Because it is a convenient sample, it is going to be biased, right? And here's why it could be biased. The location's near the courthouse, so people maybe who are in government or aware of issues might be overrepresented. There's a lot of them there, okay? So since our location is near the courthouse, people in government or who know the issues could be overrepresented. And if they're overrepresented, that would be a source of bias. Number 2, a news anchor invites viewers to call the program and express their preferences and concerns. Well, if people are choosing to come in and call the program, people are choosing to do something, that would be a self-selected sampling method. And because it is self-selected, again, it is going to have some bias. And here's why it could have some bias. People who decide to call in could either be over or underrepresented on some of their views, right? So people who are really in favor of this tax might call in and then suggest that all their friends call in too, or vice versa, right? So people who decide to call in may be over or underrepresented. Right? And depending on where that, what station that it's on, you might have people of more of one preference than the other choosing to call in. All right, a couple more here. Number 3, during the airing of the news, 500 people are selected at random from the viewing area. Then each person is contacted in a phone survey. So this is just a random number of people that are being selected because it's just a random number of people. They're not put into groups or anything like that. This is just a random sample. And of course, there is going to be some bias always, but this is probably the least biased, right? The more random you can get your sample, the least bias that you will have inside of your data. Okay, last one, number 4. The television station uses a list of viewers from a specific zip code that reflects the lowest economic income in the county and contacts residents in this area for their preferences. Okay, so they're putting them in a group, right? And then members are randomly chosen from each group, so this would be considered a stratified sample. Now, a stratified sample, not perfect, but it is going to have some bias. And here's why. If you are calling people from the lowest economic income, people surveyed are probably going to be less likely to be in favor of a tax that already takes away from like a limited income, right? So people of the low economic income are going to be overrepresented. So people in low economic incomes will be overrepresented. Right? Because you don't have anybody else to really compare to. All right. Next one, sample size and reliability. I'm going to change colors here. I'm tired of this pink. All right. The size of a sample affects its reliability. The law of large numbers states that the variation in the data set decreases as the sample size increases. With larger sample sizes, you're less likely to have a sample containing an all or nothing result. So this essentially means the more people that you can get, the larger you can get your sample size, the more reliable and the more credible that your outcome will be. Okay, so we're going to determine some adequate sample sizes. So for each scenario, we're going to say if it would be representative of the population or not representative of the population, and then we're going to explain why. So number 1. A personal trainer wants to know if adults near his local gym work out at least 3 times a week. He asks the first 50 adults that will talk to him at the entrance to a sports store on a weekday at 10 a.m. Okay, so I have to think, is this representative of his population or is this not? Well, this is definitely not representative. And here's why. If he's taking a sample of people that will talk to him at an entrance of a sports store, already that is just a convenient sample, right? And if he is sampling those people at 10 o'clock in the morning on a weekday, well, that doesn't really account for people who are maybe working at 10 o'clock in the morning on a weekday, right? So it's a convenient sample that would underrepresent adults that work on a weekday. Not only that, but he is only asking 50 people. And 50 people is not a lot of participants to ask. So 50 is also a small sample. So it's also not representative. Okay, so we always want to try to get larger. Like we're talking like a minimum of 100, always. Okay. Number 2. A restaurant owner wants to know if her customers are satisfied with the selection of entrees on the menu. She asks every 5th person who comes into the restaurant during the week. Okay. She's asking every 5th person, right? Which means, that it is a rule. And since it's a rule, this means that it is a systematic sample, right? Okay, so then I have to think, if she does it during the week, if she does it all day from morning to night, then she's got a pretty random sample, right? Because she could have new people come in. She could have old people come in. She could have like new customers versus old customers. She could have, or like regular, not old as in like an old age. But also that is true. She could have older people and younger people. So she has a pretty large grouping of different people that will be polled. So because of that, I would say that this is definitely a representative, or it is representative of the population. So it's a very random sample. And she definitely has a lot of different groups that will be polled. Right, so she's got old and young. She's got like regulars and new clients, right? So all of these are really good things that are very representative. It's a very diverse, I guess is really the great word here. It's a very diverse grouping of people. And because it's so diverse, that means that it is definitely representative of the population. Okay. Now, so we know how to sample our people. We want to make sure that our people are representative of our population. And so now, once you figured out, okay, here's the data, here's the question I'm trying to determine, here is the sample that I'm going to pick, here's how I'm going to pull them. The last type is, what kind of study are you going to do? So a study, if I'm given a statistical question and a reasonable sample, I have to figure out, okay, what kind of study am I going to do to determine whatever it is that I'm trying to find, whatever my question is. How many people like jelly donuts? How many students listen to music when they do their homework? Whatever my question is. So there are 3 different types of studies. The first one is an experiment. An experiment involves randomly dividing a population into 2 groups and applying a different treatment to each group, and then measuring the difference between the treatments. So there are 2 different groups here. You probably have heard this before, I would assume, in your science class. There is the experimental group, and this group will receive a treatment. Then there is the control group, and the control group will not receive the treatment. So this could be something like if you're trying to study, I don't know, if eating or if taking a certain vitamin helps you lose weight. There's a good one. The experimental group would take that vitamin, and then you would see if they would lose weight. The control group would not take that vitamin. But in order to make these 2 believe that they're both getting the same thing, right? You don't ever want your people to know if they're part of the experimental group or the control group. You can give the control group something called a placebo. And so that could be something like if I give the experimental group like the real vitamin that actually I'm trying to test the drug, I would give the control group like a vitamin that was filled with like just water, something that wouldn't really change them in any way. So the first type of study is an experiment. The second type of study is a sample survey. A sample survey asks every member of a randomly selected sample the same set of questions and records the answers to try to draw a conclusion about the population. So if I have a survey that's literally me saying, here's 10 questions, I'm going to ask the same 10 questions to my entire sample, and I'm going to kind of collect this data and figure out, okay, what's the answer to this question that I'm trying to find. Okay, so it's essentially, it's a survey. But what's important is that they're given the same set of questions. You cannot change them depending on who they are. You have to ask the exact same question to everyone. Last type is an observational study. Now, with an observational studies, I'm sure you can kind of guess, you do not give them any kind of treatment. So you're not giving them, a vitamin, you're not giving them anything. You are just simply observing a grouping of people. The subjects are already affected by the treatments under investigation. You're not giving them anything. You are literally sitting there watching them, what they do. So at the very beginning, Felix over here, where he just sat in the library and just watched students if they were listening to music or not listening to music, that would be considered an observational study. If Janica actually went up to her friends and asked them physically, hey, do you listen to music while you're studying? And they gave her a yes or no answer, she was doing a sample survey. She was asking them all the same questions and getting her answers. So they were 2 different types of studies. Okay, last thing we're going to do for our last 3 questions here, we're just going to determine the type of study. So we're going to determine if it's an experiment, if it's a sample survey, or if it's an observational study for our last 3 questions here. Okay, number 1. A newspaper polls randomly selected residents in a town about which mayoral candidate they prefer. So they are polling randomly selected residents. They're polling them, so they're giving them a survey. So if they're giving them all the exact same questions, this would be considered a sample survey. Right? So you're asking every member of the sample the same set of questions. Oh, come on, it's dying on me. So you ask every member of the sample the same set of questions, and you record the responses. And then obviously you would analyze them. After you recorded them, you figure out what everybody said. Okay, that's a sample survey study. Easy. All right. Number 2. A doctor conducts a clinical trial of a new blood pressure medicine by prescribing it to half the patients in the study and measuring the effect it has on their blood pressure. So he's giving a group, it looks like a new blood pressure medicine, and he's only giving it to half of them. So this would be considered an experiment. Or an experimental study. Right? So he is giving the new blood pressure medicine, so that would be a treatment, right? The new blood pressure medicine that is given to the experimental group. And then he's measuring, he's obviously he must be giving, maybe he's giving a placebo to the control group, maybe he's not, but then he's going to measure the effects of the treatment. Okay, last one. Guys, I hope you like this stuff, because this is just, I feel like it's math, but it's not math, and it's easy, and it's cool, and it's fun, and I love it. Okay. That's a side note. All right, last one. Number 3, a grocery store wonders how many customers bring reusable grocery bags to the store. They have an employee stand at the checkout and count the number of people using reusable bags. So they're not asking anybody a question. All they're doing is standing there and watching. So this would be considered an observational study. So what they're going to do is they're either going to measure or they're going to observe the members of their sample. And what's important is that they're going to do it in a way that they are not affected by the study. Right? So it's not like I'm giving them anything. I'm not giving them an experimental, whatever, and a placebo or having a control group. I'm just simply observing them. I'm not giving them a poll. I'm not giving them anything. I'm just watching them. They're not being affected by the study itself. They're not being hurt or hindered or whatever. So because of that, it's just considered an observational study. All right. Now you are ready to complete your week 4 video 2 homework. It's going to be very, very similar to kind of the examples that we went through within this. So you have to make sure that you realize your sampling methods are really important, knowing those 6. Identifying bias is going to be important as well within a study. Determining if you have an adequate sample size, and then of course the type of study that you are going to do. And start to think a little bit about, if I asked you to do some kind of study, maybe for an end of chapter project or something, what you would do and how you would ask people around you. If you would, do a survey, if you would do an observation, or if you do an experiment. So start to think about that because you can expect to see something that has to do with that very, very soon. All right, so that's it. You guys are ready for your homework. Make sure you turn it in to Edmodo. And thanks so much for watching. Also, I miss everybody dearly. Make sure you're staying home and staying safe. Okay, goodbye.